Sorry about that, Abe. Nothing personal. Alright, now what we're going to do is dissolve the zinc and copper into some hydrochloric acid. And that's just the water. I have to apologize for the background sound here. I just want to make sure that I'm not going to get a lot of hydrochloric acid fumes. I'll go ahead and pour some of this on here. And that's having a nice vigorous reaction there. Alright, so we should be getting ourselves some nice zinc chloride and copper chloride, and hopefully in about the ratios that I'm looking for, of the copper being parts per million level. We'll see, but gotta go clean up a little bit of spill over here, and we'll just let that sit and do its thing. I expect the zinc will go pretty quick. I'm just not sure how fast the copper will go, so I'm gonna just let that go for a while. Okay, now after sitting for a day or two, the zinc is all dissolved. In retrospect, I realized I probably would have been smarter to cut the pennies up into pieces that were a little bit smaller than just halves, because what was happening is the acid had to get inside to be able to get to the zinc. Now, it doesn't appear like very much copper is dissolved into there, but that's probably fine because we're looking for parts per million concentration of the copper in this. So I can see down at the bottom that there is some stuff that has been, at least that's probably the inside of the copper. So it does look like there's probably something that's dissolved in there. Worst case scenario, you can always add some afterwards if it comes to it. So what I'm going to do then is just filter out the stuff that is solid and get the liquid there, and maybe do this in a way that's not going to be as awkward with that. And it's probably still an acidic solution, so that's why I'm going ahead and just wearing the gloves, because this hydrochloric acid is actually pretty strong. And just get the rest of that in there, and get some nice shiny, hollow pennies there now. Probably not worth doing much with it, but you know. All right, and then there we go. So this is the now clean zinc sulfide, not zinc sulfide, zinc chloride, and probably, hopefully, a little bit of copper chloride in there. And the next step on this is going to be to bubble some hydrogen sulfide through this and precipitate out the zinc sulfide and doped, again, hopefully with a little bit of copper sulfide. Well, I evaporated down the penny there. It looks pretty nice there. Main reason to evaporate it, aside from concentrating it, was to try to get the some of the acid out of there. So now what I'm going to do is just going to show that this is not really luminescent on its own. So I'll turn on the UV lamp here and turn off the lights. So pretty much it's just reflecting the UV. It's not actually showing any like luminescence on it. Okay, so now after evaporating that to drive off any of the HCl, I've redissolved this into some water, minimal amount, and now we have a solution of zinc chloride and trace amounts of copper chloride in there. And so what I'm going to try to do is I want to make copper-doped zinc sulfide nanoparticles. And what I need to do is displace the chlorine ions with sulfur. And zinc sulfide and copper sulfide are both going to be insoluble in water. They should coalesce into nanoparticles, and then we'll end up with, the chloride will go away into other forms. Now, one way to do this is to use hydrogen sulfide gas and bubble it through there. That's really not something I'd like to do if I could help it. I mean, I can make hydrogen sulfide gas, but yeah, it's just not a pleasant thing to deal with. And, you can find plenty of ways to do it, but it's a fairly dangerous stuff. And so I need to have something else that is going to be a water-soluble sulfide. And sodium sulfide is a preferred way to do this. The trouble, though, is that that's actually not easy to make either, because when you try to make it, you usually end up with a polysulfide, and that's not necessarily the same thing, so I'm not sure how well that would work. But instead, I found out that there is a ingrown toenail pain reliever, and this stuff has on the back of it sodium sulfide. So we're going to take this here and mix it in with this. Now the only thing is this stuff is a very gel-like material. So I'm going to need to mix this in with a little bit of water to thin it down first. Otherwise it's just going to be like squeezing toothpaste into this. So I'm going to... All right. I'll just get all of this in there, and yeah, you can see just how this stuff is. It's a fun fact. I know for sure that they're not lying about the sodium sulfide, because I did a little test with this in another solution that turned out to be acidic, and I started producing hydrogen sulfide gas, which of course really started to stink. It's like, yeah, that's some pretty odd stuff there. So, anyways, there we go. Nice big goober of that, and I'll add a little bit of water to this. Okay, try to mix this up. See if we can get it to be at least a little bit more liquidy here. Yeah, that's dissolving pretty well there, so that's good. But yeah, that's some weird stuff. But anyways, yeah, the one reason why I decided to evaporate off down all of the zinc chloride was because of the fact that trying it on a small sample ended up very clearly and obviously producing hydrogen sulfide, which, one, as I already said, I wanted to avoid that, but on top of that, that meant that all the stuff that was going into gas form was not going to be reacting, and so wasn't going to be all that useful. It's still kind of a little scummy in there. I should add a little more water, I guess. Yeah. I don't know. Yeah. I guess I will add a little more water. Alright. Now, hopefully. Alright, that's better. Still some stuff in there, but I don't think I'm going to worry too much about that. Alright, now we add that to this, and then what we will end up with is a double displacement here. The zinc and copper chloride, the chloride ions will swap over with the sodium, make sodium chloride. The sulfide will go into the mixing with the zinc and the copper and make an insoluble copper zinc sulfate, or properly zinc copper, because copper is pretty trace amount. All right, that's a lovely sound. All right, so now oh, yeah, I did forget to actually take a UV image of the of this, but it doesn't actually make any. It doesn't have any fluorescence to it. So the two initial solutions, the zinc chloride and this toenail medicine, do not fluoresce on their own in the UV. All right, now let's take a look at this, because it is taking on a color already, which if I zoom out, it'll be a little bit easier to see that, which was not present in the initial ones. So this kind of yellowish tint that it's taking wasn't there before. And so that should be the indication that the nanoparticles are starting to form. And what we can do is let this sit for a little while and just let the reaction continue, because it's probably not going to be something that happens right away. Good thing is there's nothing really stinky in here, so that means that we're not generating any hydrogen sulfide gas which was kind of a concern. If there had been any of the HCl left in there, it would have been, but yeah, these things floating on the top are the stuff I couldn't get mixed into the water all the way. Just looks lovely. All right, so again, you can see a kind of yellowish color to that, which a famous YouTuber is established is the sign of a chemical reaction gone bad. But, well, in this particular case, this might be what we're looking for. So we'll let that sit for a while longer and just we'll see what happens. So I've decided to heat the solution up a little bit, and mostly, I'm doing this down in the basement, and it is almost the end of March, but it's still cold down here, and so reaction might not be going quite as fast, but I think you can definitely see a lot more of the yellowish appearance on it. And looking down inside, it's not easy to see, but you do kind of get an impression of a kind of reddish hue, more due to the scattering of light that I'm thinking I'm seeing. Okay, so now you can really see a yellow color on that. And so that is definitely a result of the nanoparticles being formed. You can see how hazy the liquid is now. So I would say that that has reacted, and I could run this to just evaporate off some of the water and concentrate it, but I think the first thing I'm going to try doing is actually just running, putting under the UV light, and we can see what it looks like.